All right, so how did the homework go? So how many of you figured out the trick versus wrote the gigantic if statement? How many of you did a huge if statement that became annoying after, well, I guess with cut and pasting, it probably it probably wasn't horrible, but certainly it was annoying. How many of you got the trick?
Tried. So what's the trick?
Well, I'm going to show you the trick. But so at the end of class last time, we looked at string.find. I want to try something here. I think these last two parameters are optional, but it would have worked for you anyways. So let's let me go ahead and test that real quick. And we'll do this. Let's do print. Find S, what I'm searching for. Let's do an E. So let's see if just that works. If I just say, don't tell it where to start and where to finish if it looks through the whole thing by default. Yeah, it does. All right, so since we were specifically looking through the entire string, we didn't actually have to specify start looking at 0 and stop looking at length of S. It means the same thing, but those were optional parameters. Remember from last time, we were looking at the documentation for 3, but this gets back to that whole, the competition between 2.7, Python 2.7 and Python 3, whatever. So Python 2 versus Python 3, there's some syntax changes, and sometimes the documentation mixes the two and that kind of stuff. So that's why even today there's still some competition between those. Okay, so let's talk about this trick. So the homework assignment was to go through some string, and was it print consonants? Is that what we were doing? So go through a string and print out all the consonants we find in the string. Now, an important thing to remember is consonants does not mean not vowels. Because things like numbers and question marks, those are not consonants. All right. So, one thing you could have done is, maybe just for a cheat sheet here, I'm going to go ahead, I'm going to write the entire alphabet, then I'm going to go through and remove the vowels. And I'll go do my uppercase version of that too. Okay. Now I'll go through and get rid of the vowels. All right, so there's all of our consonants, upper and lowercase, right? Okay. Now I'm going to go ahead, we're going to put in a, let's see, we'll call the string test, and we'll do hello again. So we should get HLL for this guy if we wrote our code correctly, right? Okay. So one thing we could do is we could, we start off by looping through all of the characters in our string, right? Because we want to test each character. So, we'll do our we'll see for a character in test, do some stuff. So each time through, C will become the next value in this collection. We talked about that last time. So now we've experimented with two different ways of generating, one way of generating a collection. We have two different collection types that we know how to go through. So we know how to generate a collection of integers using the range function, right? So if I say range 0, 10, it'll generate for me all the numbers 0 to 9. Okay, so that'll give me a collection of integers. Or we have a string representation here for a collection. Okay. So if I just print out these values here, just as a review, this will print out each letter that is inside of the string test. So this will do H, then E, then L, then L, then O. Okay, so let's see that guy run. So there's H-E-L-L-O. Okay. Well, now we want to ask some questions. So again, we got our repetition, we got our asking questions, we got our memory, so we're still working with those fundamental things. So each time through here, we want to ask some questions. Now, some of you asked a very giant question, right? Where you said, if it's a B, or it's a C, or it's a D, or it's an F, or it's a G, or we could do that, right? You just keep stringing the ors together, and that's effectively what we wrote last time, right? But we wrote it for vowels, and it was less scary looking. All right, some of you said you wrote that. It's going to be impressive to look at. Is that kind of like that length if statement, the Boolean expression? What's a Boolean expression again? Any expression that boils down to a single value of true or false. All right, so now the trick, and this isn't, I mean, I keep saying trick, but I really keep connecting this. I use Home Depot very often, right? So we've gone to Home Depot. We've purchased this string.find thing. All right, we brought it home with us, and we think about, oh, what are all the different things I can use this guy for based on the things it does? All right, so string.find gives you the position where it first finds a character in a string, or a -1 if it is not found in there. -1 if it's not found in there. Now I happen to have a string containing all of the consonants. If I go through this string and I say H, and I look for H inside of the list of consonants, what will I find? What value will it give me? Here, let's rename this guy to consonants. All right. So I'm going to look for this H inside the string of consonants. It's going to be there, right? So what's that? 0, 1, 2, 3, 4, 5. So it's going to find that H at bucket 5. All right. What about the E? It won't find it. What does string.find return when it doesn't find a value? What does string.find return when it doesn't find a value? -1. Turns -1 if it didn't find the value. So if I happen to look for a character inside of consonants, and it gives me anything other than a -1, that must mean it's a consonant. That means it found it inside of that string, correct? Otherwise, it's not a consonant. Okay, if it returns a -1, it's not in there. It's not a consonant. Well, I only want to print out consonants. So I can ask the question, if string.find, what string am I looking in? I'm looking in the string consonants. What am I looking for? The current character C. That is the character that I'm currently looking at it through test. And if that guy gives me anything other than -1, I don't care what number it returns, as long as it's not a -1, we'll go ahead and print C. Go through all the characters in test. For each one, look for that particular character inside of consonants. If it gives you anything other than -1, that means it was found in there. Therefore, it must be a consonant. Therefore, we'll print it out. There's our HLL. Does that make sense? So fine, when we went to Home Depot, we bought this tool. It's like, oh, I'm going to search for things in strings. So it has an obvious use, right? But because of how it works, because it either gives us the first position it finds something, or it gives us a -1 if it didn't find it, we're able to leverage that error, right? I didn't find the value you're looking for, to rule out things that are not consonants, which effectively allows me to print things that are consonants. So anytime I look for a character inside of whatever this string is, I named it consonants, and it's the collection of all the consonants, upper and lowercase. Whenever I look for this guy in here, if he gives me anything, this is not equals, if he gives me anything other than a -1, it found it in there. It is a consonant. Print it. Otherwise, it'll ignore everything else. So I can throw spaces in here. I can throw question marks. I can throw some numbers. Doesn't matter. Still get our HLL. Okay. You just can't break your list of consonants. Now, let's piggyback this on what we did last time. So now I'm going to go ahead and we're going to create another string here called vowels. So last time we cheated a little bit. We left the uppercase ones out, or we left the lowercase. I don't remember which ones we omitted, but to keep our if statement palatable, right? So now I have a collection of all the vowels here stored in this string. All I need to change down here is I'm going to search for my character inside of vowels now instead of consonants. And if I don't find it in there, it must be a, or if it is in there, that means it returns anything other than a -1. That means it must be a vowel, therefore we'll keep it. So this should return an E, an O, and that's it out of that list, right? So I didn't change my logic down here at all, except I changed the string in which I'm searching. Instead of searching in consonants, I'm searching in vowels. There's my EO. Lift this near the top of the screen. If I want to have a collection of digits, I can now search inside of digits. In this particular case, it should just give me 1, 2, and 3. Those are the only digits in my test string, right? There's my 1, 2, and 3. Seeing the pattern here? All right, so now in real life, believe me, when I assigned this, I figured maybe, I guess I was hoping that about half the class would figure out the trick. Okay, the rest of you would be able to get your points by, practicing the epic if statement and move on with life. But but in real life we do this all the time, right? When you need to solve a problem, what do they say? You could fix anything with duct tape. So we have certain things that are around the house that we apply to all sorts of problems, right? It's like, well, these two things aren't sticking together. We'll wrap a bunch of duct tape around it. Are they sticking together now? Yeah, pretty good, but maybe not good enough. We'll put more duct tape. Now it sticks together, right? It's good. Okay, so in real life, we solve problems like this all the time, taking whatever's sitting in front of us and saying, how can I apply this to the tool in front of me? How many of you have solved problems with forks and knives that have nothing to do with eating, right? You see what I'm saying? It's even though those tools were designed for a specific purpose, doesn't mean we don't apply them to other things. The same thing's true here with these tools that we're working with here. Just because we're so used to solving problems in real life, we don't. It's easy for us to think about, well, what can I use this fork for? We're here, we're still intimidated by all the crap that's on the screen and this idea of loops and if statements and all this stuff, that it's hard for us to kind of move past it and view these things as like kind of tangible tools. When they're the same thing as in real life, except they're easier to work with once we get past being afraid of them, right? Or being intimidated by working with them. Okay. I did put a note after class last time on Slack. Does everybody have a functional development environment now? Okay. So understand that if I'm not aware that you're having problems with command line stuff or what editor to use and stuff like that, I can't like review it in class or something like that. I need to know that there's a problem instead of having a bunch of people say I couldn't do my homework. So let me know and we'll try to, whether it's me or somebody else will give you the pointers. That's fine, but that's what Slack is kind of for. Make sense? But so at this point, everybody can do their homework in some reasonable way. Okay, so I'll go ahead and here so we're dealing with the exact solution to your homework. I'll copy this code and I'll post it into Slack.
It seems like with code, there's always different ways you can tackle this problem.
That's true, but so let's back that statement off and say you say it seems like with code. Well, in real life, isn't that true as well? I mean, you could use a fork, you could use a screwdriver, you could just use your hand and hope you don't cut a finger off. I mean, there's all sorts of ways we can solve certain problems, right? Same thing's true with code. I mean, realistically, we have more variables in real life. Because in real life, you basically just look around the house and look for something that might work, right? Where in programming, our vocabulary, if you will, of the things that we have available to us is always going to be a lot smaller than in real life. I don't care how long you've been programming, there are more things in real life you're aware of than you will be inside the little programming world, right? The languages, even though the languages might be large, Python is a smaller language than some of the languages like Java and C#, but not like substantially so. It's a general purpose language. It's a relatively large language. So, we're introducing one little function at a time, and that's like, we're going to Home Depot on a budget. We're buying the next tool that we need, and after 20 years, you've got a pretty decent collection of tools at home, right? So it's kind of that sort of thing, but with programming, we always have to solve problems in terms of the tools we have in front of us. So we're going to usually have some sort of limitation on the different ways we can solve the problem. Even with our assignment for today, is the version I showed you here necessarily better than the version you wrote?
It's more efficient.
More efficient for who?
Yeah.
For the programmer. I don't know if we could fairly say that it's more efficient for the computer. I mean, this string.find, this power tool we picked up from Home Depot, somebody wrote that. Somebody had to make that guy go and do some stuff. We'll write our own version of that once we introduce functions, probably next class. And we'll see kind of what that might look like. All right. I mean, it doesn't seem like it would be all that bad, does it? I mean, if we looped through a string and we said, is this equal to the character? No. Is this equal to the character? I'm just counting each way of each of these. This is bucket 0, bucket 1, bucket 2. And I get all the way to the end and I don't find the value. Then I print out a -1. Or when we start dealing with our own functions, I'll return a -1. Otherwise, I return the value where I found it. It's not a real hard thing to write, but it's dealing with some repetition. All right, we're asking a lot of questions. We're saying, is this the guy? No. Is this the guy? No. Is this the guy? No. Over and over and over again until we finally either find the guy or run out of stuff to check. So realistically speaking, we can probably say, at least in this particular question, and again, it's going to be on average because you might pick a consonant that's very early on in the alphabet. It might be faster from a computation perspective for the computer to write the epic if statement. You're asking one question. It's a complicated question, but it's one question. Where here, I'm asking a question, followed by another question, followed by another question, followed by another question. Potentially a question for every single one of the consonants. Until I finally bail out and say, okay, I didn't find it. Right? So even though it was a lot shorter for us to write here, we can't, like, with 100% certainty say that this is the better solution if you care about speed, right? But we've already had this discussion about relatively fast versus relatively slow, and the reality is computers are very, very, very fast. So if we assume that this version, my guess is probably on average it's probably about a wash. One's probably not substantially faster than the other. But let's just say that using this power tool is 10 times less efficient. It's 10 times harder for the CPU to solve this problem using our power tool rather than our epic if statement. Do you think we would notice as humans? Or is the computer solving that so quickly that the amount of time it took to print the stuff to the screen is way overshadowing the amount of time it took to do the behind-the-scenes math? We're not going to notice. Now, you start doing something that takes 10 times longer, 1 billion times. Now you might start feeling that time difference. Make sense? Okay. So only sometimes do we have to really focus in on writing the most efficient mathematical solution to a problem. Most of the time, we care far more about our own convenience. We do the same thing in real life, don't we? I mean, who cares how inconvenient it is for everybody else as long as it was easy for me? Selfish approach, and some of us might say, oh, I'm not really selfish, but if you really think about it, all of us are selfish at some level, right? It's the way it works. Now, for all of you right now, pay zero attention to being nice to the computer. Okay? Every problem you solve right now, you solve in the way that makes the most sense to you. Okay? That will sometimes be the most efficient solution, meaning the one that's the shortest amount of code. Okay? But as we saw today, many of you didn't figure out this trick for your homework. And that's okay. In fact, I'm guessing that some of you, while you might follow it a little bit, haven't completely wrapped your mind around what this trick is doing right now. And that's still okay. Okay? Sit there and look through it and stuff like that, but if it doesn't make sense to you, don't use it. Go ahead.
Speaking of non-understanding, why did you have to list the C after consonants? What does that mean?
This guy right here? I'm saying this is the string library. I'm saying string library, use your find tool to search for this character inside of this string.
One question.
Well, let me finish answering that first. So this character right here, C, this is not the char C.
Right.
This is the variable C, and the variable C is part of this for loop here. So C, the very first time through, will be an H. Then it'll be an E. Then it'll be an L. Then it'll be an L. So each time through this for loop, I'm saying look inside of consonants for the current character from test I'm looking for. Okay. Otherwise, I mean, if you say, find in consonants, what am I looking for? Okay, I got a bucket of toys here and I'm looking for the airplane. Okay, well, I have to know I'm looking for the airplane before I start digging through the bucket of toys. Otherwise, I'm just playing with toys. Make sense? Okay, does that make sense why we have the two things? And the way I'd advertised it last time, the other two things we would have had here is 0 and the length of consonants. Okay, these two guys are optional parameters, but this says, where should I start looking? Where should I stop looking? All right, so if you run into, this particular power tool that we have been introduced to happens to allow us to be even more granular. Okay, if I have, a bucket of toys that has 4 little, sub buckets inside of it, I might only be interested in looking in the top 2. For instance, not looking through every toy inside the entire container. So this guy gives you the flexibility to specify where to begin and end your search if you're interested. Does that make sense now? Okay. Go ahead.
Did you really need to capitalize all the confidence? If you were just, with confidence, and you can just limit it to those few?
Do I need to capital? You mean these guys here?
Yeah.
Well, I mean, we have upper and lowercase consonants. So if I left these guys off, for example, let's get rid of those for a second, and I happen to have one of my consonants in here capitalized, it's going to miss it.
Yeah, but if it wasn't capitalized, it doesn't with lowercase when that.
Well, I mean, yeah, then we get it, but that's just random luck. I mean, but if this guy was capitalized, we would look at this and say that is a consonant, right? But if I run this, we didn't get that capital L, okay? Because we knew as programmers that our variable consonants contained consonants. Down here, I mean, the fact that this word says consonants in it means nothing to Python. Python is just looking for this variable inside of this collection of things. Okay, and that collection of things happens to have, from a human perspective, all the consonants. In this case, it has all the lowercase consonants. All right, so it's not going to find a capital L inside that list because there is no capital L inside that list. If I go ahead and add that guy back in, now it'll find my capital L. All right, but understand that Python doesn't care what you name your variables. We name this guy consonants and vowels and digits for us, so that those guys have meaning for us, right? So this guy is the list of all the consonants. This guy is the list of all the vowels. This guy is the list of all the digits. Okay, this guy is our input, but we happen to name it test. You can name it whatever you want, or a couple of you might have used the raw input function or something like that to actually read some input in. For right now, I don't like to muddy the waters too much with that, but here, I'll show it to you real quick. So we'll say, I think the book introduced input, but I think all the examples of input had always done numbers, reading numbers in. Because I think we saw this last time. So I'll go ahead and run it using just input. This is the function the book introduced. So now what we're doing is I've given myself my search collections, even though I'm only using consonants here. But instead of hard coding in the value I'm going to be wanting to print all the consonants from, I'm going to now get this from the user. And actually this takes in a prompt, right? Enter the test string, let's say. Something like that. So this will prompt the user, enter the test string, and read it in and store that result inside of this variable, rather than us hard coding it in here and having to change it each time we want to test something different. We don't. In fact, it's wrong. But I was testing you. Java, C#, all those, you would need the semicolon. Yeah. This one, it would have given here. Let's look at the little error message, Oh, actually, it allowed us to have it. That's funny. That is interesting. Didn't you say that it wasn't working on yours? For reading in just input? Yeah, last class. You said because you had to use raw input.
Yeah, it for some reason wasn't.
I wonder if you're using a... So it worked once and then it didn't work? Yeah, no, I got you. That seems to be working, so that makes me question, because I looked at his code, and his code looked fine. I wonder what version of Python you're running your code with.
I think it's 3.5.
No, I mean, so anything 3 should be fine. I don't know, that'd be interesting to look more into. But let me show you both just in case. Because in Python 2, the input function was something called raw input. Like this. So that's where I'll have to look up some stuff sometimes because I've taught this, I haven't taught this class in Python before. I've taught Python several times and I've taught in both languages, so there's some mixture between what's there. But this kind of goes back to this idea of once you know one language, you know them all. Just have to look at the documentation a little bit real quick and hammer out how it works in this particular language. So that'll be good because you'll see it from a real programmer's perspective. But raw input, I think, still works inside of Python 3. Oh, it's not. It's not defined in Python 3. So that tells me that you must be using a Python 2 interpreter.
Interesting.
So this was a Python 2 function. In fact, I'll run this. I think the rest of this is legal Python code. Yeah. So that's running in the Python 2 interpreter right now. The default interpreter on the Mac that comes pre-installed on your Mac is Python 2.6 or 2.7, something like that. So that worked. It had heard of raw input in Python 2. But Python 3 had never heard of raw input. They took it out of the language, replaced it with just input. Which kind of makes sense, right? You want to input something. Why do you have to say raw underscore input? It's kind of like extra crap to type, which means something simple. But the problem is a lot of people had a bunch of... So most of the updates they made in Python 3 made sense. But because you had so much pre-existing code in Python 2, to drastically change the language like that breaks a bunch of old stuff. Make sense? That's why there's still this kind of war between, do we move over to Python 3 or stay in Python 2? Because if you're a company that has a whole bunch of code written in Python 2, and all your stuff is executing through that same interpreter, the Python 2 interpreter, well, if they're going to start writing new stuff, that means if they're going to choose Python 3 for their new stuff, they have to convert all their old stuff over to Python 3. Because it'll be extremely inconvenient and possibly impossible in some cases to have half of your stuff running on one interpreter and half of your stuff running on another interpreter. You kind of want all of your, it's called code base, all of your files to be in the same language, right? Okay, so they have to make that decision. Do you move over to Python 3, which makes you convert all your old stuff over to Python 3, or do you stick with Python 2 and write new stuff in Python 2? Another real-life example of this is there's a very old language we didn't cover because I typically don't like talking about languages that are older than Dr. Locklear. But there's a language called Cobol. Okay, a language called Cobol. Still used heavily today. And Cobol is ancient. Cobol is a really old language. But it's used heavily today for this exact same reason. For instance, Northwestern Mutual has a big group of Cobol programmers. One of our one of our students who just graduated last semester, Nick Largen, is working at Northwestern Mutual as a Cobol programmer. We don't teach Cobol here, but he had all of our languages, went and learned Cobol in a week, and moved on with life, and he's making good money now writing something that's ancient. Well, Northwestern Mutual, pretty big company, right? Been around for a while. Well, they have a whole lot of software written in Cobol. So if they want to move to something more modern, they'd have to convert all that old stuff over to something more modern. Do you do that, or do you maintain the old stuff and write all your new stuff in the old language? That's what they do. My wife is a Cobol programmer. She, the university I used to teach at, I've been here, this is my 11th year here, but I used to teach at Western Illinois University. I started there in 2000, and she was a Cobol programmer there. We use Banner here, right, which is a third-party product. So we pay for Banner. Some other company writes it, and it's for student records stuff at universities. Well, at Western Illinois University, they don't use something like Banner. They could switch over to it, but for a long, long, long time, they've written all their student record stuff and all those reports and things like that in Cobol. So rather than converting everything over to Banner and paying a yearly fee for Banner, which in the long run probably would save them money, but in the short run they couldn't afford. That's actually kind of the funny problem that you run into. They still have a collection of like 20 Cobol programmers that work at Western Illinois University who update old programs, write new programs, all this stuff in this ancient language. And what I mean by they can't afford to do it now, if they were to move to something new, let's say, I mean, I don't know exactly the number of programs they have, but let's say they have 1,000 Cobol programs that get used all the time, okay, by different departments on campus and running different reports and stuff like that. To take those programs and convert them over to, let's say, something like Java, it costs a lot of money to do it in the shorthand. You have to bring in hundreds of developers to all convert these programs over. Then you'd have all the bugs you got to work out and stuff like that. So I mean, it might be a multi-million-dollar project to convert old stuff to new stuff before you can officially move over to the new stuff. Or they can kind of just keep paying the $250,000 a year for the developers to maintain what they have. In the long run, you're going to spend a whole lot more money keeping what you have now. But in the short run, that's what you can afford. So that's kind of an interesting dynamic you run into today. You are starting to see, though, companies like Northwestern Mutual and things like that starting to convert their stuff over. So they have two groups at Northwestern Mutual, the Cobol people and the Java people. And what they try to do, like Nick Largent was one of these folks, he knows Java and he learned Cobol so he could work on their conversion. So they're moving stuff over to the newer languages. But a company like that, I mean, they have a lot of people's insurance dollars. So they maybe have the money to kind of rip the Band-Aid off, absorb a huge, huge, huge bill over the next 1 or 2 years so that they save money in the long run. Where a state university in Illinois that hasn't passed a budget in 2 years maybe has a problem floating that type of thing. Okay, so any other questions about what we have here before we kind of go to the next thing? Okay, so what we want to talk about next is we're going to introduce a couple of new tools. So I want to look at string concatenation. All right, concatenation is a fancy way of saying glue strings together. That is to say, hello, concatenated with world will give me hello world. All right, that's what concatenation is. Taking two separate things, gluing them together, but a string must be involved. All right, so let's look at this. All right, so the concatenation operator here, there's a couple different ways of pulling this off, but I'm going to show you the kind of simple concatenation operator initially, because there's also a way to format strings. In real time, we're not going to worry too much about that right now, but is the plus sign. But that plus sign gets treated as the concatenation operator when there are strings involved. So let's dump this stuff, and I'll say A is equal to hello, B is equal to world, C is equal to A plus B. Wonder what he's trying to accomplish there. And then I'll go ahead and print C. So C should be hello world glued together.
Well, you could just do print hello world in one line.
Yeah, but then you wouldn't have a variable that contains hello world glued together that you could use for other things.
Oh.
Yeah, I mean, I could print whatever I want here, but that's not going to give me that value to use again. In this case here, I can print C 3 times in a row. I'm proving that I have a variable here that contains these two strings glued together.
So you create a variable you can only keep using.
I can keep using it. Yep. I'm remembering stuff, right? Variables are our memory. So I'm remembering 3 different things here. I remember the string hello. I remember that little bucket called A. I remember the string world. I remember that little bucket called B. And now I remember in a little bucket called C, whatever A and B were glued together. So that's going to be hello world. So I'm remembering 3 different things here. That make sense? Now, just to drive a point home here, let me run this real quick so you'll see hello world glued together 3 times. What would happen here if I say,
Wouldn't the computer be confused with A stuff?
oh, I mean, that's the question here. So I'm going to change A to elephant. So A has changed.
So
So I used to remember hello. Now I'm thinking now that hello has been replaced by elephant. The question is what's going to print right here? Will this be hello world or this be elephant world?
It'll print hello for the afterward and elephant class too.
Okay, so you think hello world here. Nothing's changed here. Now I've changed A, and now you think elephant world.
Yeah, I think.
You don't think so? Why not?
Because it goes from top to bottom and you're never like referring back to that.
Okay, that's a true statement. So we'll start off with this. You're right about the output. The output's going to be hello world, just like it was before, all 3 times. Okay, you say because it goes in order, which is also a true statement. Variables always resolve to their most local definition. This variable A right here will resolve to hello. This variable B right here will resolve to world. So effectively, that's what I've written there. So even though I changed A down here, that had no impact on what A actually resolved to up there. Okay? I used A and B there as placeholders, but before I stored anything inside of C, A turned into the value it held. B turned into the value it held. And at this point, we're just dealing with string literals. Hello and world glued together, stored in C. That make sense?
Yeah.
So even though we can look at this and say, oh, well, these two guys, C is defined in terms of A, that's true, but it was only defined in terms of A at that point in time. Once we got down to here, once we got past this line, C was already set in stone. C had a value, and that value was hello world. And that does not change if we change the value of A later on.
I thought the computer could use that.
I mean, you can do things like that, but you'd have to do it on purpose. You'd have to, we don't know how to do that yet, but the point is that if you want something to have a side effect, if you want to change some, remember when we were talking about the history of our languages, we said, in a language like C++, you can choose to pass the house or pass the address where the house lives. In this case, A is the house. Okay, so when I get A right here, I'm dealing with a copy of it. Okay, that resolves to it. So anything that happens to A right here has nothing to do with this other copy of A down here. Okay, because we're not dealing with the same memory address. Now, and we don't know how to do it yet, so I can't show you a concrete example, but the point is, had I decided to define C differently, I could make C kind of track any changes in A. That might happen. All right, but as it is right now, this is going to be, and here, let me explode this out a little bit. I'll print A and B first. So this will be hello. This will be world. This will be hello world. Then I'll print A and B again after this line. This will be elephant. This will be world. But this will still be hello world, hello world. Hello world, or hello world, hello world. Then we print out A. Well, we changed A to elephant. Then we print out A. We print out B. Print out C. Print out C. Make sense?
So if you did A plus B like you did for the hello or when it my elephant world.
So if I do this, if I repeat this line down here, I change C to be the same line it was before, but now A and B are changed. Now it'll say elephant world. I'm changing the value stored in C to a new value, and even though it looks the same, the way I'm building it as it did up there, A actually has a new value. So now it'll be elephant world. Make sense? All right, so that's one power tool that we have. Well, some tools are power tools. This is more of a tool. All right, so let's look at a couple other examples here. So now I'm going to say num is equal to 5. So we want to see what happens. We know that that plus sign, when we apply it to two numbers, gives us addition, right? 5 plus 3 will give me an 8. Okay? But now I'm using, and we saw that this plus sign, when applied to two strings, will give me another string. It will glue them together. That's the concatenation operator. So the same operator, the plus sign, is both the addition operator as well as the concatenation operator, depending on what kind of values on which I'm operating. So what's going to happen here when I try to take a string and add to it a number?
I think it's gonna leave it at +5.
So it's because this first thing was a string. It's moving from left to right. Because A was a string, it's saying that num must be a string, not an int, in order for this plus sign thing to work. Now, in languages like Java and C# and Swift, this would be allowed. Okay, because those languages are strongly typed languages, and it would say this guy was a string to begin with, therefore when I ran into this, it must be the concatenation operator, and I don't care what kind of value this is, I'm just going to glue it onto the end. I'm not going to do math with it. But in Python, because it's a interpreted language, which also means it's a loosely typed language, these things are all happening during runtime. So it has to do this left to right. We're not able to make these decisions ahead of time. We're not compiling the language beforehand. Okay? So if I want to glue this number onto this string, I need to turn this number into a string. All right, and that might be what I want to do. So let's go back here. I think this is the tool to do that. Let me test it real quick before yeah. So A is already a string. Num, we know, is the integer 5. This tool says turn whatever this guy is into a string. Now, it needs to make sense, right? I mean, we haven't dealt with objects yet, but if you put an ice cream cone in there and say, turn that guy into a string, it probably doesn't make a whole lot of sense. But if we say, here's the number 5, I want this to become a string, we expect that guy to ultimately produce that for us, right? That's what we want to happen. We want the number 5 to become the string 5. Make sense?
Yeah.
All right, so we're going to call these conversion tools. This guy converts val into a string. Similarly, we have one called int that converts val into an int. Let me show you that by example real quick. So I'm going to store in C the int version of the string 5. The integer version of the string 5 should give me the number 5. So when I say 5 plus 2, I should get a 7. Correct? That's what we'd expect to get there. There's my 7. Similarly, I can do that with bigger numbers, and I should get a 58. This will also work on chars. So there's the char 3, turn it into an int, so now it'll become should give me a 5, right? All right, make some sense?
Yeah.
All right, so let's see where we are in our reading. We're not quite to where the next homework assignment is. We're up to, what have we read up to at this point?
2-2 or
Yeah,
2-3? I think 2-2. Wasn't in the last one.
Okay. So let's go ahead and let's finish chapter 2 then for next class. That'll catch us up because now we're actually ahead in class. So read chapter 2 for next class, do all the exercises. Next class, we're going to come back and we're going to work more with number conversion stuff. We're going to write a program that does that. All right? I will see everybody on Wednesday.